Welcome. Please turn to section 3.5 of your guided notes. By the end of your lesson today, you will use long division and synthetic division to divide polynomials. Let's quickly review what long division looks like, in case you're a little rusty. So let's start by dividing 187 by 3 using long division. So we would set up our little division here with this sort of table to separate the divisor from the dividend. Now 3 does not divide 1, so we skip over it, but 3 divides 18. In fact, 3 divides 18 6 times. So 3 times 6 is 18, that goes here. And then this is a positive 18, you notice that. We now change it to a negative 18. Positive 18 minus 18 is 0. And then you go ahead and take this 7 here and bring that down. How many times does 3 now divide 7? 3 divides 7 twice. 3 times 2 is 6. And again, this is a positive 6. Let's go ahead and change its sign to a negative 6. Positive 7 minus 6 is just 1. Now, what did we just do? We showed that 187 equals 3 times 62 plus 1. This here is our divisor. Here we have our quotient. And then here we have our remainder. Now let's discuss the division algorithm. Given a polynomial f of x and a non-zero polynomial divisor d of x, where the degree of d of x is less than or equal to the degree of f of x, there exists unique polynomials q of x and r of x such that f of x equals d of x times q of x plus r of x. Here, q of x is the quotient, and r of x is the remainder. As you can tell, this corresponds to precisely what we did up here. We have our divisor times our quotient, plus the remainder. Of course, if the division is even, say if you're dividing 3 into 27, you would have no remainder, and this would just be a plus 0, which you would then omit. Same thing here. If you have no remainder, you just omit this, and you have your divisor times your quotient. Let's look at example 1. Example 1, using long division to divide polynomials. Use long division to perform the following operations. So let's go ahead and write out our divisor x minus 5 outside of this division table. Inside we write our dividend, 2x squared minus 9x minus 5. How many times does x minus 5 divide this 2x squared? Let's just look at this leading coefficient. What times x will give me 2x squared? 2x. 2x times x is 2x squared. 2x times negative 5 is negative 10x. Now we're going to go ahead what we did above and change the sign of each term. So this 2x squared is negative, this 2x squared is positive, so it becomes negative. This 10x is negative, so it becomes positive. Now, positive 2x squared minus 2x squared is just 0, so I'm going to leave that blank. Minus 9x plus 10x is simply just x. And then we bring down this last -5 we have not used. If you notice, x minus 5 divides x minus 5 exactly one time. If you notice, x minus 5 divides x minus 5 exactly one time, so this is plus 1, and we multiply this to get another x minus 5, and then you can subtract and add. These add up to 0, and you end up with a remainder of 0. So this tells us that 2x squared minus 9x minus 5 equals x minus 5 times 2x plus 1. Since our remainder is 0, we don't add anything to the end. So we have here our divisor times our quotient equals our original polynomial. Let's try the same thing for example B. So again, our divisor goes on the outside of our division table, and then our dividend goes on the inside. 16x cubed minus 12x squared plus 20x minus 3. What times 4x gives me 16x cubed? I know that 4 times 4 is 16, so we should have a 4 here. Then x times what is x cubed? That's right, x squared. So we have 4x squared times 4x is 16x cubed. Then 4x squared times 5 is positive 20x squared. Now let's go ahead and change both our signs. This first term is positive, so it becomes a negative. This second term is positive, so it also becomes a negative. Negative 16x cubed plus 16x cubed is 0. Negative 12x squared minus 20x squared is negative 32x squared. Now let's bring down this 20x. It is really important that you don't skip any values of x. So let's say I didn't have a 20x here. I would want to just write out 0x. So I have an x cubed, x squared, and x. You should have every single factor. So if you have an x to the 4th, you would need an x to the 4th, an x cubed, an x squared, an x, and so on. So we're bringing down our positive 20x. Now, what number times 4 gives us negative 32? That's right, it's negative 8 times positive 4 is negative 32. And then we have a single x here, but we want an x squared here. So we need to multiply by another x. So this becomes negative 32x squared. 8 times 5 is 40, and this is negative, so we make this a negative 40, then an x. This is a negative, so it becomes a positive, and this term also becomes a positive. So we end up with 20x plus 40x is 60x. Now let's go ahead and bring down this last negative 3. 4 times what gives us 60? That's right, it's 15. So we have 60x plus 75. Now let's go ahead and change our signs. This is a negative, and this is also a negative now. So we end up with negative 3 minus 75 is negative 78. So we have our final answer of 16x cubed minus 12x squared plus 20x minus 3 equals 4x plus 5, our divisor, times 4x squared minus 8x plus 15, our quotient, plus our remainder, and it's a negative, so I'll just write minus 78. In this case, our d of x equals 4x plus 5. Our q of x equals 4x squared minus 8x plus 15. And our r of x equals negative 78. And these coincide to the definition of the division algorithm towards the top middle of this page. Let's turn to the next page of section 3.5 notes. Synthetic division is a shortcut that can be used when the divisor is a binomial of the form x minus k. So we have to have something of this form. We can't divide, like our previous examples, by a squared term or a cubed term. Only the coefficients are used in the division process. So let's use synthetic division to perform the following operations. I have x cubed minus x squared minus 11x plus 18 divided by x minus 2. So since we want this of the form x minus k, we know that x minus k, we have to have x minus a positive 2. So k just equals 2. So this will go on the outside, and then we draw this kind of upside down division table. And so what are the coefficients here? This has a coefficient of 1. The x squared term has a coefficient of negative 1. The negative 11x term has a coefficient of negative 11. And the constant here is just a positive 18. Now the first step you always do is just bring this 1 down. Next, we're going to multiply 2 times 1 and write that in here. 2 times 1 is 2. Now go ahead and add these up. Negative 1 plus 2 is 1. So now we multiply 2 times this 1 is also 2. Negative 11 plus 2 is a negative 9. Now let's do our final multiplication. 2 times negative 9 is negative 18. 18 minus 18 is 0. And this last spot here is where our remainder comes from. And we have a remainder of 0. So what did we just do? We showed that when we divide this polynomial x cubed minus x squared minus 11x plus 18 by x minus 2, so this polynomial is equal to x minus 2 times x squared plus x minus 9. So x cubed minus x squared minus 11x plus 18 equals x minus 2 times x squared plus x minus 9. Let's go ahead and look at the next example. So our k in this case is negative 3 because x minus negative 3 would give us a term of this form. So we have negative 3 on the outside of our upside down division table. Our coefficients are 1, 2, negative 3, 2, and positive 6. We bring our 1 down for our first step. Negative 3 times positive 1 is negative 3. 2 plus negative 3 is negative 1. Negative 3 times negative 1 is positive 3. Negative 3 plus 3 is just 0. Negative 3 times 0 goes here, and that's just 0. 2 plus 0 is just 2. And then finally, negative 3 times 2 is negative 6, and that gives us a 0. So we have x to the 4th plus 2x cubed minus 3x squared plus 2x plus 6 equals x plus 3 times x cubed minus x squared plus 2. Notice this 0 coincides with the x term, and that's just gone. These values are always 1 degree lower than the original polynomial, so we started with an x to the 4th, so this should be x cubed, x squared, x, and the constant term. So it's just x cubed minus x squared. There are no x's to the first power, so that's just left off, plus 2, our constant term. Now let's look at an application problem. Example 3, using polynomial division in an application problem. The area of a rectangle is given by 3x cubed plus 14x squared minus 23x plus 6. The width of the rectangle is given by x plus 6. Find an expression for the length of the rectangle. So let's recall from algebra that length times width equals area. We're told that the area of a rectangle is equal to 3x cubed plus 14x squared minus 23x plus 6. So this is the area here. We're also told that the width of this rectangle is given by x plus 6. And if you notice, I used this information to replace both area in the formula and width in the formula. Let's find an expression for the length of the rectangle. So we start by dividing both sides by x plus 6. And we end up with L equals 3x cubed plus 14x squared minus 23x plus 6 divided by x plus 6. Now we can use synthetic division to finish our division. You could also use long division for this, but since I'm running out of space, I'm going to stick to synthetic division. So our k in this case is negative 6. Again, because this can be written as x minus negative 6. So this value of negative 6 is what goes on the outside of our division upside down table. On the inside we have a 3, a 14, negative 23, and a 6. Negative 6 times 3 is negative 18. 14 minus 18 is negative 4. Negative 6 times negative 4 is positive 24. Negative 23 plus 24 is just 1. Negative 6 times 1 is negative 6, and our remainder is 0. So that means our length can be expressed as, well, first ask yourself, what is the degree of this polynomial, of this solution? Our original polynomial had degree of 3. So this is a degree 2. So this is 3x squared minus 4x plus 1. And this concludes the lecture for section 3.5.